Hi, everyone. Welcome to the next session, which is a conversation with science. I'm delighted to welcome Frederick Otto, who's going to be joining us virtually, unfortunately not with us here today in person. She is a senior lecturer in climate science from the Grantham Institute for Climate and Environment at the LSE, and she's dialing in from London. Freddie was on an amazing panel yesterday called The Climate Court, looking at cases of climate injustice. So if you didn't catch that session, I'd really recommend you also take a look at that. But today we're here to hear from her and for her to present some of her work at the cutting edge of climate science. So we'll have about 15 minutes for Freddie to present to you, the audience, and then we'd love to take some virtual questions and in-person questions. So if you'd like to prepare those, we will moderate them between the in-person room and Freddie, who's with us on the screen. So enjoy, and Freddie, take it away.
Thank you very much. To confuse everyone, I'm indeed at the Grantham Institute in London, but not at the LSE, but at Imperial College, because there are two Grantham Institutes in London. And I'm a senior lecturer in climate science, and my work is primarily on extreme weather event attribution. And I'm going to talk now a little bit about what that means and what we can do with it, and hope that you have then lots of questions, so that I can say the things that are actually of interest. So when we talk about climate change, and also particularly here in Glasgow, most of the discussion is around global mean temperature and stabilizing global mean temperature at 1.5 or at 2 degrees and cutting emissions, which of course is crucially important and essential to be able to hold climate change. But quite often in this discussion, we talk about 1.5 degrees or 2 degrees or any of these goals as if they were a cliff, which we will fall, if that's reached, then we will fall down. But forget that actually the era of loss and damage from man-made climate change has long begun. Climate change is not a bomb that will explode at a certain temperature target or a certain level of emissions. But with every bit of warming, the impacts of climate change are getting worse, which of course in turn also means that every bit of warming that we avoids worse impacts. So this is particularly striking when we think about what actually the impacts of climate change are. What is climate change? Climate change is not primarily global mean temperature, but climate change manifests through changing likelihood and intensity of extreme events for most people, in combination then with sea level rise and changing seasons. And we have known for a very long time how greenhouse gas emissions and global mean temperature are connected, and that burning fossil fuels leads to more greenhouse gases, and that in the atmosphere, which leads to higher global mean temperatures. And we also have known for a very long time that this will manifest in changing likelihoods and intensities of extreme weather events. But until the beginning of this century, whenever extreme events happened, people were asking the question, what's the role of climate change? Because many of us already knew then that climate change is a thing. And the scientific community did not have very good answers to that question. There was one standard answer that was given, which was, it's impossible to attribute individual weather events to climate change. And the other answer that was given was, climate change is happening, global mean temperatures have increased. So of course, the weather that we are experiencing today is different from a world without climate change. And so climate change does play a role. And the latter is trivially true, but it doesn't explain what the role of climate change is and how climate change affects the weather events that we are experiencing today. And this has changed. So within the last decade, scientists like myself and many others have developed um, the scientific method that is called extreme event attribution. And that the aim of that science is to really answer the question whether and to what extent man-made climate change altered the likelihood and intensity of an extreme event that has occurred. And this is quite a mouthful what I just said, but it's really important to say it in that way because language matters when we want to talk when we talk about climate change and when we want to understand how climate change is affecting our lives and that of everyone else in the world. Often when an extreme event happened, like for example the major heat wave hitting Canada and northwestern US in June, or the drought that is still going on in Madagascar currently, the question is often asked mainly by media, is this climate change or not? And that's the wrong question because there is no yes or no answer to that question. Every extreme weather event has always multiple causes. There's always a role to play from just the chaotic variability of day-to-day weather, but then other factors like what was the preceding season of that weather event like? Was it dry? Was it wet? Where is the event happening? Is it happening over a city, over forests? All that plays an important role in how hot a heat wave gets, and also how much rainfall will fall. But we can answer the question how climate change has altered the likelihood and intensity of an event to occur. And to do that, we need first to know what is actually the weather event that is happening and that we are currently experiencing. So coming back to the example of the heat wave in Canada and the US, it was what was really extraordinary about this heat wave was that the daytime temperatures were so high. They reached almost 50 degrees in Canada. And the geographical area of that heat wave was around a relatively large area, including Seattle, Vancouver, and Portland, so highly populated area of that part of North America. And so when looking at the heat wave, one way to define it was to look at the extreme high temperatures in that particular area. And so in an event attribution study, once you have to find out what is the event, so how hot was it where, or how much, what rainfall actually led to the flooding? Was it a one-day extreme rainfall event, or was it more the whole season was very soggy, or did it actually rain somewhere else and just because of the hydrology and the water management it flooded in the areas flooded? Once that question is answered, we can then use statistical models and state-of-the-art climate models and find out this event that we have just defined. What kind of event is it? And to do that, we need to simulate possible weather in the world we live in today. And so for the heat wave in Canada, we might find out that even in today's climate, which is already 1.2 degree warmer than it was at the beginning of the Industrial Revolution, this event is still very rare, and it's about a 1 in 1,000 year event. So every year you have a 1 in 1,000 chance of such an event to occur in that area. But then to find out what the role of climate change is, we need to identify what is possible weather in the world that might have been without climate change. And because we know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution, we can remove these from the atmospheres of state-of-the-art climate models and also use statistical modeling based on observations to simulate the world that might have been. And then in the case of the heat wave in North America, we found that in the world without climate change, such an event would have been extremely unlikely to occur. It would have a 1 in a million chance to occur, which basically means that this is the kind of event that climate change has made possible, that would have been almost impossible without climate change. But what we also find with event attribution studies is when factors other than climate change were the primary driver of an event. So another example is a drought that affected Sao Paulo in 2014, which led to massive water shortages and had huge impacts. And doing a study on this event, we found out that in today's climate, it's about a 1 in 10-year event. But also in the world without climate change, it's about a 1 in 10-year event. And looking back at the observational record, we found that a similar kind of event happened earlier in the noughties and also in the 1970s with much fewer impacts and damages. And so then looking at what else has changed, we identified that on the one hand, the population had increased massively in the last 10 years before the drought occurred. But what had increased even more was the water usage, which increased almost exponentially. And so that was the main driver of the massive damages that turned this weather event into a disaster. And so these are two examples of possible results of attribution studies. A priori, there are always 4 possible results. One is climate change made the event more likely. Another one is that climate change made the event less likely, for example, with frost or snowfall events, that what you find quite often. The other one is what I just explained for the example with the drought in Brazil, where climate change did not play a major role. And the other one, the fourth one, is the climate that we don't have currently enough data and our models are not good enough to answer the question for that kind of event. So these kind of studies do exist now, and we have, for the first time, event attribution studies have been assessed comprehensively in the most recent IPCC report, which has been published in August this year, where for heat extremes and heavy rainfall events and different types of droughts and also tropical cyclones and compound events like fire weather, so combination of hot, dry and windy weather leading to an increased likelihood of bushfires, have been assessed. And the IPCC provides an overview of what we can say about these different types of events, where mainly all heat waves that are occurring today are made more likely and more intense by climate change. But this is not true for other types of extreme events. So for heavy rainfall events in large parts of Asia and Northern Europe, North America, and parts of Africa, we do see an increase in the heavy rainfall events because of climate change. But in many other parts, we don't. And partly this is because the climate change signal has not emerged there. And partly it is because we don't have enough studies to assess in the IPCC, because the IPCC doesn't do science on itself, but just assesses published studies in the academic literature. And so if there are no studies, then the IPCC cannot make an assessment on that part of the world. So there is still a huge gap in terms of what we could in principle say, where we could do studies and where we actually have studies. And this discrepancy between the global north and the global south is very apparent when it comes to extreme events, and also when it comes to where we do know the role of climate change and where vulnerability to extreme events is particularly high. So we have lots of studies in the global north where vulnerability is of course existent, and it's also in the global north that those most vulnerable are the ones who pay for these extreme events with their lives, with their livelihoods, and also the economic costs. But in the global south, we have a lot fewer studies, and so huge gaps in understanding what does climate change actually mean today, which is important if we want to build resilience, if we want to address the drivers of disasters, because in some cases they might be climate change, and in some cases they definitely are. But in other cases, there are changes in vulnerability and exposure that turn extreme events into disasters and also need to be addressed. And so it's important to understand where is the event that we see a harbinger of what's to come, because climate change is playing a big role, and where are other drivers of risk, other factors of risk and vulnerability and exposure, major drivers of the damages and losses, and so that we can address all of them accordingly. And so to finish, I would just like to say we have made a huge advancement in the science when it comes to understanding what climate change means on the local scales, on the scales of weather, and on the scales where decisions on resilience and adaptations are made. But there's still a huge amount of work to be done, in particular in the global south, and to understand to disentangle the drivers of climate change and vulnerability and exposure. So we now have a lot of the tools we would need to put an inventory of the impacts of man-made climate change together, but we don't have that inventory yet. I hope that was interesting, and I hope you have some questions for me.
Thank you very much. Hi, Freddie. This is Wolfgang Blau from the Oxford Climate Journalism Network. And I have a very practical question from the perspective of news organizations. And that is about the time it takes between an extreme weather event and the news cycle of reporting about that event being active, and how long it takes for us to be able to attribute it to climate change or not. Is it, assuming you have the data that you mentioned that is missing for so many parts of the world, but assuming there is historical data and other data, is it safe to assume that that time span will become shorter in the next years?
Well, yes, I very much hope so. And this is a really good question, because at the moment, there are very few people in the world who do these kind of study, and especially who do these kind of studies on a short time scale, hoping to be able to provide scientific evidence within the news cycle. And so the main bottleneck for us is manpower and not data availability or anything else. And there are some initiatives trying to operationalize some of these studies for the more straightforward events, so for heat waves or large-scale heavy rainfall events. I very much hope that they will be funded soon, because there has been pilot projects that have shown that it is possible to do this, but they at the moment are not funded. But I think asking the question repeatedly and just also showing how important this information is also for journalists might help to speed that up.
Hi there. I've heard that climate change will cause weather patterns in places like the North Sea to change dramatically. Do you think that policymakers and renewable energy companies are thinking enough about what the places where they build new infrastructure will look like in 20 or 50 years, and whether these will still be the best places to do so?
Yeah, that it depends on what kind of weather events you're vulnerable to, how much, and to what extent they are changing. So I think if those who build this infrastructure are aware of their vulnerabilities, so if it's for heat or for sea level rise or heavy rainfall, then we definitely have enough information to make these choices of where is it safe to build what. But I think there is still a huge gap in our public understanding of what the role of climate change in different types of extreme weather events is. So, for example, that heat waves, which are by far the most deadliest extreme events in the global north, in the global south, they might be, but we don't know because they are not recorded. For heat waves, climate change is an absolute game changer and really makes events that would have been impossible possible, and not only possible but also frequent. For other types of events, the changes are slower and less dramatic. But of course, if you are highly vulnerable to flooding, then building infrastructure at any coast is not a great idea, because sea level rise is one of the major impacts of climate change, and also one that will continue to rise when we have reached net zero CO2 emissions.
Hi there. You've talked about how you can use your statistical analysis to estimate what previous extreme weather events and the likelihood that climate change has contributed. Forgive me if this is naive, but is there any feasibility now or in the future that you can use real-time weather data and your statistical analyses to predict future extreme weather events?
Yes, we can. So this is absolutely not a naive question. I think it's a very good question, because these methodologies that have been developed to attribute present day events to climate change, and so compare them with a hypothetical past or a past without climate change, these methods can be used in exactly the same way to estimate how. So, for example, the example I used at the beginning, the heat wave in North America this summer, which is in today's climate about a 1,000-year event. In a 2-degree world, this type of event would be happening every 5 to 10 years in that region. So we can use, and we are using, these methodologies to look also in how, under different plausible futures, these kind of events are changing.
Thanks for your presentation. What do you think, or what is your best sense of what the state of event attribution science will be during the next IPCC review, if you could predict for the future?
Ooh, that would require me to predict quite a lot, because I don't actually know how exactly the next IPCC cycle will look like, and whether there will be an AR7 that will be exactly the same as AR6, the assessment reports. But assuming that there will be a report in probably again another 7 or 8 years time, I would assume that, or I would very, very much hope that event attribution will be applied more broadly also in the global south, and also for the types of extreme events that where we currently have very little information. So on fire weather, for example, and on heavy rainfall and droughts in parts of the world where at the moment we don't have a lot of data. But I think what I would really hope what the next IPCC cycle would be that we don't have one report on the physical science, and one report on impacts and vulnerability, and one report on mitigation, but that we have combined information on all these dimensions at the scales where we need to make the decisions. And I think event attribution can play a role because it can provide a lens to identify vulnerability and exposure drivers as well as the hazards. And so I think we could use this science to develop, to better integrate the different lines of evidence even more in the IPCC reports, so that we don't have these separated silos anymore.
If there is another question right now, this is Wolfgang again. Freddie, in terms of the economic interest, or who benefits the most economically from your work and who is most likely to fund it maybe? Is that the insurance industry? Is it media? Who needs your work for their own business the most?
So I think the work is needed for any kind of planning decisions on local scales you want to make that requires some information about the changes in extreme weather. So it's definitely something that the insurance industry is interested in. It's not interested in the way that they pay for it, because our methods and results and models and everything is publicly available, so they can just use it. They don't have to pay us to do it, which is a bit unfortunate. But and I think it's also very important for the media, because it allows just scientific evidence to be part of media reporting on extreme events, and it is absolutely important that we report climate change when talking about extreme weather events, but of course in a way that represents the true footprint or fingerprint of climate change. And these kind of studies are also used as evidence in court cases, so in climate litigation cases. So that's another area where this kind of science can provide important evidence. But I think ultimately event attribution, together with observations and future projections, will help us to understand better our own vulnerabilities to climate change, and so just have better adaptation planning on national scales. That doesn't answer the question who's funding it, but I think it's important in lots of different areas.
Thanks, Freddie. Does anyone have any more questions? Yes, one more, Freddie.
Hello, I'm intrigued by, is that an exact science? Is there full-blown agreement across scientists about, yes, this prediction is correct, or is it a bit of a black art still? I mean, if I may cite a scientist you may have heard on, Donald Trump pretended that was not true, and of course this is an extreme, but among real scientists, is there full agreement about the findings?
Well, I think the fact that it's one of the major new advances that are reported and assessed in the IPCC report, which is a very good indicator that there is large agreement on the usefulness and also the trustworthiness of this kind of science in the climate community. It's real science in exactly the same way that all that other climate science and other hydrology and or natural geography is real science. So it's science between the natural sciences and people, And so it's science between natural and social sciences, which makes it which makes it maybe slightly different from particle physics, where you have particles that follow the statistics, but no people interfering with it and having varying levels of vulnerability. But it's the laws of physics hold for attribution science, as well as for climate projections, as well as for all other sciences.
Thank you, Freddie. I think Freddie deserves a round of applause for what a great presentation.